as usual, this webinar is what you have asked us for. You've asked us to look at predictive maintenance for your airfield lighting. We've talked before about the need for compliance, and unashamedly we will refer to that again, but also the method of ensuring the methods for measuring compliance, photometric testing, of course. But it's once you get into the best practice of measuring your lighting on a regular basis, and it's the photometric testing, it's the inspections, it's the torque testing, it's checking your circuits, it's doing the PPMs, cleaning your lights, so once you've got into the practice of doing these things, you're then in a position to be able to use this data to perform a very useful function, that's predictive maintenance, to fine-tune your maintenance practices to not only ensure compliance, but efficient compliance. And that's the topic on which Keith is here to talk to you today. I'm pleased to introduce Keith to you, but also our panel, our expert panel. So we've got Tony Smith here, inventor of the PAPI, who's very kindly, who's very much the father of MARMS, indeed, because it was his initiative that with the UK CAA that very much led to the development of photometric testing as we know it. So again, huge thanks to you, Tony, but also Robert Billingham, who has developed the software to allow you to view all the MARMS information on the dashboard, all of the reporting systems that we now take for granted and that are integral to the development of predictive maintenance in our industry. And also thanks also go to Damon and Felicity, without whom we couldn't, today's webinar would not be possible. But first of all, if I could hand over to you, Keith. Thank you.
Okay, good afternoon, good evening, good morning, or wherever we are in the world. I think we're all pretty used to now talking across the time zones. And that's certainly one of the positives that have come out of the difficult times of COVID in the past, and has been the acceptance of virtual discussions across the big communication network that we have today. Predictive maintenance has, well, to be quite honest, when we talk about predictive maintenance, and if you just bear with me while I click onto the next slide, then it was actually talked a bit futuristic about, oh, can we predict maintenance? Yeah, we can predict maintenance. We can predict to do things like block lamp changes. We can predict to do something every week. We can predict to do something every month. But can we actually record those results in real time? And can we then be able to observe and monitor the performance, the condition of our systems? So that is what we do today. And that is probably the difference between what we have known as predictive maintenance and what is in reality in our new world of condition-based maintenance or performance-based maintenance. And you'll see this slide on here. We always say you cannot manage what you do not measure. And that's very valid, isn't it? Because if you want to be able to maintain and to do some planning, etc., you really want to look at the performance of the units, of the equipment that you have, and say, is it performing to standard? If it is not performing to standard, that is why we do preventative maintenance, to prevent it being defective and not meeting the required operational requirements. So condition-based maintenance and performance-based maintenance. But what is it? We need to understand what it is. And when we're looking at the whole of our airport and our airline industry. And we know that aviation has gone through so very, very difficult times in more recently. But we look at airports, we look at airlines, we look at the regulatory requirements associated with that. We look at 4 basic elements. We look at all the equipment that we use. We look at the tools that and backup facilities that we use. We look at the processes and the procedures that we use, and then we look at ourselves. We look in the mirror, and then we say, are we competent? And it's either a yes or a no to each of those 4 elements. So when we're looking at this whole aspect, and we now look at the ability and use technology in our digitalized world, then can we improve? And the answer is a yes, we can improve, because when we're looking at performance-based maintenance or condition-based maintenance, the reality is we measure, we look at the results, and we make decisions associated with those results. And therefore the timescales, what we actually do in terms of maintaining serviceability is based upon all that information. And the beauty about our digitalized, our internet work, you know, the internet thinking of today is that we can do it in real time. And that's what we're going to really discuss today. So when we move on and say, well, you know, you cannot manage what you do not measure, what is it we're actually doing? Well, you need to understand what your runway and your taxiway and your apron is to really understand what is it we're achieving. We want to get as many aircraft operating safely on our airport so we can maximize the service that we give to the traveling public. We know there are difficulties currently, and everybody sees the press everywhere and the media. But when we're looking at those equipment, then as soon as we install equipment and commission and start to maintain that equipment, then it starts to deteriorate in one form or another. And so we look at the life expectancy of the equipment. We look at the environment that we live in. Do we live in the desert regions of the world? Do we live in the Arctic, the cold, snowy regions of the world, etc.? And those seasonal factors, because just because perhaps we live in the Arctic, we always assume Arctic conditions is exceedingly cold, but it can be very, very hot in the summer, in the summer period. So you get these various seasonal factors, which are variations. All these factors affect how we actually operate and maintain our equipment. So that's what we mean by learn your runway. But of course, the equipment that we have, you learn your lights. Learn your lights. Photometric is only one aspect. I mean, that's the end product. But how do we get that photometric output? We have to look at it from an electrical viewpoint, a civil viewpoint, mechanical viewpoint, etc. And of course, there are only X number of suppliers around the world, reputable suppliers of equipment around the world. And we have, as an airport, have to choose which ones we're going to install and operate on our airfield, and follow the process and the guidelines from those suppliers. So learn your lights. So let us look no further. Right? Let's look no further, because today, more than any time in history, and when we started to look at, when we're talking about the asset, this started many, many, many years ago. The difference between the 1990s, the late 80s and the 1990 period is when we really started to look at can we measure light output in the field? And the answer was, yes, I think we can. So the development started. And as Robert has explained, Mr. Tony Smith has been integral as part of, from the concept of measuring performance out in the field up to the present day. So we are very, very, I'd say, you know, Tony, you're our godfather in this. Thank you. But can we measure? Can we maintain? Yes, we can. We have the tools, we have the equipment, and what we're going to do is explain a little bit more about the variety of tools and equipment that we have today, available today, and be able to get the records in real time and be able to analyze those records in a proactive way, And I'll take you straight into the MARMS dashboard. Now, I'm going to introduce Rob Billingham in a few minutes, who's going to explain a little bit more in depth about the dashboard and how the integration of the MARMS engineer technologies and the tools that are involved associated with doing the measurements out in the field, whether it's electrical measurements, whether it's civil engineering, mechanical engineering, or just purely photometrics. So there's a whole range which Rob's going to explain. And I'm going to introduce particularly here the newest of the tools, really, which is really the photometric measurement capability of signs and PAPIs. Because from my own personal experience, then PAPIs, pretty fundamental. If I was going to choose an AGL system to install first for flight, for safety, for landing on a runway, I would choose a PAPI. Let's get a PAPI in first, right? And of course, Tony will, as explained in previous webinars, in great depth, a lot about the PAPIs. But of course, when we're talking about conspicuity, what do we mean by that? You know, legibility, comprehensibility, credibility. What do we mean? So, Tony, maybe I could ask you to jump in here and give a little explanation about this side of it for just for a minute or two.
Yeah. Okay. Yeah. Those four words are important. They describe, if you like, the basis of all of visual signaling. Our airport lighting is a visual signaling system, and these requirements of any visual aid, visual cue, have to be met wherever it is, on the land, at sea, or in the air. And in the case of the airports, the conspicuity issues there are, when I say conspicuity, what we're talking about here is, can I easily see it? Does it stand out in the field of view that I'm looking at, day or night? Does this aid, which I need to see, is it easily found, or do I have to search for it diligently in a whole mass of other cues, and I find it difficult to find? I mean, it's the other end of actually deliberately hiding yourself, which is a thing the military try and do, of course, by making the thing non-conspicuous, make yourself invisible. We want the aids to be very conspicuous, and this can be a real challenge if you think of the airport situation, where there are literally hundreds and hundreds of light sources. And if you think about during the approach phase, you're approaching a city airport, perhaps, an awful lot of lighting there. Can you even find the airport in amongst all of that? And particularly, can you see the central visualization, able to line up your approach and make the correct descent into the runway? It needs to shout at you the visual information, so it's easily seen. It needs to be conspicuous, I suppose you can look at it another way. If you try and read a book in very limited lighting, you find it very difficult to light. So you apply more light so you can read the text easily. The text is conspicuous. That's so important. It's very basis of the whole thing. And then legibility is okay. Take a sign, for example. Someone else will say it's conspicuous. I see this big red blob, if you like, out there somewhere. But can I read what it says? It's no use being able to see the sign if the legibility isn't there, if I can't easily see it and read it. And then from that, what is on the sign, is it comprehensible? Does it make sense, what I'm seeing? Does it really make sense? What does 26L mean? And does it fit in with my understanding of where I am at the moment on this airport? I remember talking to some of my former test pilots who had then gone into the civil world and flying the airlines. And I said to them, what is, when you're flying airlines, what is the thing that concerns you most? And they said, it's going to the airport that I don't normally go to, or I'm going to the first time. And feeling confident that I know where I am. And so the signs are vital to know that you're where you think you are, or where you think you should be, and that you're not, for example, transgressing an active area, inadvertently going onto a runway. So the system of signs has to be comprehensible. And then going along with that is credible. You have this information, you understand it. Does it make sense? Can I believe the information? So whatever you have in terms of visual aid, that is all those four aspects have to be addressed. And the solution you come up with has to make those four items possible. You can see it, you can read it, you can understand it, and you believe the information it's giving you.
Yeah, thank you, Tony. I think that's an excellent explanation, and from everyone, who's joined us from around the world, to have that explanation in that such a clear way, Tony, that it is comprehensible, it is credible. Thank you. Thank you very much. So what I've done next is to go into and bring into really the mechanical side, and here that I've introduced the MARMS engineer, the Imanj engineer, which of course enables us to collate to carry out the functions and collate the information, etc., for Rob to be able to present all that information to us. So I'm going to introduce you now, Rob. You'll have to demute, of course, which you have done. Yep. And what I'd say now, maybe this is the correct time to say, over to you, mate.
Okay, thank you.
More information.
Thank you, Keith. Good afternoon, everyone. Right, so MARMS dashboard, you've heard me present this thing many times. It's a whole set of tools and reports for proving your compliance. It's also got tools there for predictive maintenance and investigating issues. There's more to it than just a set of compliance reports. It's a tool that you can use every day to help you in your jobs and in your diagnostics. So could you move on a slide, please, Keith? Oops, that's two. That's it. So on the photometric side, the reporting we have for compliance, it starts off at the dashboard with a set of runways and ticks and crosses to whether they're compliant or not, and are they Cat 1 or Cat 1, 2, 3. If you drill down from there, you drill down into runway serviceability reports, which is top level management report, then into course bar charts, where we show the percentage of standard of each lamp on an individual course of the runway. And then if you want to investigate a particular fit in itself, see what's going on, we can drill down again into what's called the Isocandela reports. Now these give us a lot of information about alignment of the fitting. Is the brightest part of the beam within the ellipse on the chart? It shows us the elevation and the azimuth, and we can see, is the beam pointing too high? Is it towed in the correct way? You might have a fitting that's in the wrong side of the runway, and you can see that from the Isocandela diagram. And also, the Isocandela shows us a history of reports, of results over time. And it has multiple pages. You can flick back and you can see the image change over time as the light gets dirty. The percentage of standard degrades. And if we do a simple trend of that information, that can be an incredibly powerful tool. So that there is a link on this report to drill down again into, it's called photometric performance history. And we're simply plotting the photometric results, percentage of beam standard for the forwards direction and the reverse direction, if it's a bidirectional fitting. Over time, we can see when it drops down below that 50% of standard, which is the IKO pass level. And we can start to identify maybe the lamp life length. What's the cleaning interval that you should have? So the trend of lamp aging is far different to the trend of the light getting dirty. So we can see the lamp starts off good, and then it drops down when it gets dirty. Maybe it drops down to the 50%. You clean it, it jumps back up. But then over time, we've got this gradual degradation, and we come down to really low level where perhaps cleaning isn't really cutting the mustard anymore. We need to relamp that fitting. So we're looking at, for a halogen fitting, relamping every 12 to 15 months. But you can start to look for these trends yourself if you examine the data that's there. Okay, so next slide, please. Okay, so another tool is the course bar chart, as I said, where we look at the percentage of beam standard for each fitting on a course. And these are color coded. If the fitting is below 50% of standard, you get a red bar. If it's between 50 and 70, that's recommended maintenance, you get a blue bar. And then above 70%, it's a nice pass, a green tick. If we take that color scheme and we put that onto a map, which is another tool available within the dashboard, we can see geographically where the failed fittings are, and we can start to look for patterns. And here we've got two lamps which are out opposite each other on the runway. So could this be an electrical problem? Could it be a circuit issue? Or could we be looking at jet blast? If we examine where's the TDZ on the runway, and which, if you look at takeoff and landing directions and where the failed lights are, could we be looking at a jet blast situation? Maybe we need to look at changing lenses, relamping. We can look for geographical issues which you can't see from just the course bar chart reports. Next slide, please. Okay, so if we take our photometric results and we add them to MARMS Engineer, which is yet another suite of software and reports, we can import our photometric faults into MARMS Engineer, and we can combine this with the results of visual inspections, torque faults, and we can come with a whole picture of where the faults are on the runway, and what is our asset status, our asset serviceability for the whole airfield. So we show this in two ways. There's the fault status panel. So this shows by area. So we divide the airfield up into areas logically within your runway, your taxiway, miscellaneous assets, your CCRs, however you want to organize it. And we just simply have a number of faults per area. And then as an additional warning, we also show you in a red badge, we show the number of faults which are over 30 days old. So these are the ones you should really be targeting, because they've been there for quite some time. Then the asset status panel, this one shows us a percentage of assets which are good on the airfield. So if a particular area drops below 95%, then we flag that up as a warning. You can see that there's a shriek on runway 1. So we should be drilling down into there and see what's happening. Next slide, please. So if we drill down into a particular area, we then organise our assets by zone. So a zone could be a centre line, an edge, TDZ, runway end. So we can see where our outstanding issues are. Anything that's over 30 days old within a particular zone, we get a red bar. And if everything's above 95%, we get a green bar. But then we can drill down again into a zone and look at tabular data and consider the individual faults within that zone. So it's worth noting that an AGL asset is both sides of a light fitting. So although in your photometrics, an asset will appear in 2 runways, in the Marms engineer system, it just appears in one area and a zone as a single asset. So a photometric failure on either side could give us a fault, which is shown here. And also, we don't just record faults for AGL assets, but the system can monitor all assets on the airfield. So we're looking at CCRs, transformers, even windsocks, anything that could have a fault or need cleaning or torquing could be monitored by the Marms engineer system. Next slide, please. So here we're just drilling down into the asset status report, so to the tabular level. So we can see 33% assets are okay, which isn't good, and we can see where those faults are. We see most of them shown here are Marms low intensity faults. So these are faults which have come in from the trailer. And you set your bar there yourself. We set it to 70%. You can raise the bar if you want, which many airfields do, so that your fault level is much higher and your expectations are more. So as I said, this also combines faults from not just from your trailer inspections, from visual inspection and from your torque maintenance as well. So you can have a torque fault, a bolt that's where the thread's gone or something like that, that these all appear within this asset status. Next slide, please. Okay, so if we take those faults and we put them on a map, just like the photometric one I showed you earlier, this is the Marms engineer map. So we can see the location of all these faults. We can click on any particular asset and see its information. We can see what the most recent fault is, who reported it and when, and if there's any remedial action scheduled yet on that asset. It's not scheduled here on this one, but we can take this fault and we can give it to someone to go and fix. We can say, fix it tomorrow night. That job's yours. It will appear on your tablet for you to go out there. We can color code the faults as well. Each of the faults within the Marms engineer system, the low intensity, lamp out, torque faults, cable faults, all the different types of faults you can have in Marms engineer. You can set up different colors so that they don't just all have to be red. And I've already mentioned the remedial action scheduling, and you can close down faults on the map here as well. Okay, so next slide, please. If you've got a particular asset you're investigating and you want to really drill down into it, we've got something called the asset information report, where you can put up a complete audit trail for that asset. So everything that's ever happened to it, we can see its current status. It's photometrically tested in both directions. It's been torqued, it's been cleaned, it's currently serviceable. But then we can go and look at its last 10 faults and its recent torque information. If we carry on to the next page, we can see its last photometric test on both sides. We can see the course bar charts where involving that fitting, and also see the isocandellas. Now, Again, isocandelas are very important in diagnosing issues of alignment issues. We can see whether the light is towed in the correct direction, whether it's too high, too low. Here, interestingly, we can see at the bottom of the isocandela chart, there is a dark area there. So that could mean there's some contamination of the lens right at the bottom of the fitting there. Or it could be that the light is set below the pavement level, and that's actually the tarmac. So there could be some issue with the can there, but that will reduce the overall percentage results, because we consider all of the samples taken within the ellipse area. So on the right hand side there, we've got this trend, but this time we bring into play the Marms engineer data. So we've got cleans shown in orange, and we've got relamps, repair or replace in pink or purple. So we can see when we have a clean, we should expect a much better photometric result next time. And then if we have a relamp, we should reset, we should go right back up to the top. But if we combine the cleaning, the relamp and the photometric results, we can really start to identify this lamp life length and the cleaning interval, which will help you plan this maintenance, so you can predict how often we should be cleaning, how often we should be relamping. And then at the bottom, we've got a complete maintenance history, color coded in the same way as the chart. So we've got the blue and the green photometric results, the cleaning and the relamps, and also combining it with everything else that's happened to the fitting every time it's been torqued or any other maintenance it's received. So all the information's there. Next slide, please. Back to the map, we can do clever things like pull up a heat map, so we can look at where most faults occur over time. So if a fitting's in a darker red colour, that may have had 10 or more faults over whatever period you choose. And then in orange down to yellow and white, less faults. So we can look for hot spots on the runway, see where the faults are occurring most often, and fittings that may require more investigation. Next slide, please. The survey history report is a relatively new development. Here we look at the last 12 surveys on both sides of a fitting, both sides of a course. So here we're looking at a centre line in both directions. Each row of the table is a fitting, and each cell is a photometric result, colour coded in the same colours as the course bar chart again. So we've got the red, the blue and the green with the percentage achieved in each cell. And then on the left, we've got an average percentage, also colour coded. So we can see over this period of time, what's the average photometric result achieved. Also got a couple of extra metrics there. Hash maint gives us the number of faults that have occurred over this period. And then hash recent is the number of times it's failed in recent times since it was last good. So these two metrics, we can use those to filter the report, and we can just go out and attack the repeat offenders. If we go out and do that, we must make things better. Again, if we combine the Marms engineer information, so we know when these have been cleaned and we know when they've been relamped, we can add to the report an orange line for when it's been cleaned. So we can see there we've cleaned the whole centre line. We've got a massive improvement on the next survey, but we've still got a few lamps here and there that are still not improved, not by much. So we may want to relamp them. So we mark those in pink. And then on the next survey, we've got a huge improvement. So we've still got a few repeat offenders there, which we need to not improve by the clean. So we need to get out and perhaps investigate those further. Okay, next slide, please. So we worked with an airport that did a cleaning study, trying to identify how often they should be cleaning their lights. So we're looking at a centre line and the edges over a 17-day period. starting with a very clean runway. So I've had a deep clean and we're at 100% serviceability across the board. Then we start to look at what happens. So we're regularly photometric testing every day. And we can see after 3 days, centre lines come down to 98%. And a couple of the edges have come down to 96, 98. And then we carry on this, we monitor over time, 5 days, 7 days, and we're down to 87% on the centre line after a week, 70% on the right edge there. Okay, so now we decide it's time to go and clean them. So we'll test them before we clean them, and then we'll test them again afterwards. And then we're back up to, so we've only cleaned the edge, we're back up to 98%. We're still at 84 on the centre line, we've not cleaned that. Then we have a de-ice event. So we've dropped to 77% now on the centre line, and this is only after 12 days. So we're almost at after 14 days, we're at 3/4% of serviceability after 2 de-ice events. We're at 45% on one of the edges, 39%. So we need to clean for safety reasons. Okay, so we clean everything, test again, and we're at 89%. Not as good as it was after the deep clean. So it should be noted that, you know, cleaning must be done properly. You know, we still, the clean that has been done there isn't great. The conclusion of this study was that the runway needs to be cleaned every 8 days or after every de-ice event. That was the conclusion, which is every 8 days is quite often. So the MARMS cleaner, the MARMS manual cleaner is certainly a tool that should be considered to keep up with that cleaning regime. Next slide, please.
Whoops, sorry.
So the dashboard has got a whole wealth of reports. There's a whole library of reports you can use there. It's to understand it all fully. Some training may be helpful. So you know that is available to you. If you want to contact us, it certainly can be arranged. We can do training sessions on photometric reports, MARMS engineer, the photo bench reports, and the new sign PAPI stuff as well. So yeah, please contact us if you need more information. Next slide, please. I'll hand back over to Keith now. Why AGL performance is so important.
Okay,
Yeah.
thank you very much, Rob. And that excellent. And I'll just drop back, you know, to your overall thing there about training and familiarization. Of course, we now, of course, give virtual training as well as face-to-face training. And this has been, you know, brought to bear that we had to do this really during the you know, the inability to travel. But of course, hopefully, you know, face-to-face training is clearly always the best, you know, because, but it is both virtual and face-to-face training on site as required. Why? Why is AGL performance so important? It's because we need to have safe operations. We need to have equipment that is compliant. We need it for our direct customer is the pilot, and he or she needs to get the best visual cues, and especially in low visibility conditions. And it's important for the airport itself. The airport needs to be able to maximize the capacity of their facility safely. And at the end of the day, the airlines themselves who are going to use and pay to use the airport wants to be sure that they can minimize delays and of course any costs associated with the potential diversions because of non-compliance. And it's normally specifically because of low visibility conditions. So the importance of our visual aids amongst all the other electronic aids is all about safety and compliance. So what are the benefits for you as an airport? The benefits for you as an airport for adopting performance-based maintenance, because that's where we are today. We're, as Rob has just explained, the tools and equipment that we have is available to you. It's available to you and you can use it in real time. So you can make decisions, both long-term preventative maintenance decisions, but also fast-track breakdown maintenance decisions. So the whole package of being able to monitor, record, and make those decisions in real time is exceedingly important. Very, very important. And of course, if we have equipment that is performing according to the requirements and the standards, then the pilot will be happy. It'll look about that legibility, comprehensibility that Tony spoke about, in terms of the amount of times a pilot say, can I see it? Oh, is it too bright? Is it, oh, I'm being, you know, all those kind of things. Or, and if a pilot does not have comprehensible and legible information from our visual aids, then he's going to sit still. I'm not going to move. I don't know where I am. I can't see where I'm going. All those kind of things. That's going to increase the CO2 emissions from the jet engines of today. So very, very important. Hence, also, then when we are going to low visibility procedures, and wherever we are in the world, there are going to be times, for example, if we're in the Middle East and that early morning mist that occurs, or the sandstorms, or, you know, for example, we have you know, the environmental issues with wherever, or we're in Asia Pacific and it's the monsoon season, for example. All those elements then are taken into account when you're measuring performance, and you make the decisions associated with the performance. And therefore, if an air traffic control and operations can make a decision to go to low visibility procedures at a later stage because of the effectiveness of the visual aids and other things, then it's important you get accurate RVR readings to make those decisions. So key advantages, if you do have effective, and let's take LVP as an example, go to low visibility procedures. If you can delay going to low visibility procedures because of the effectiveness of your AGL, then we did an investigation with an airport, and it turned out that they gained 37 minutes before they went to low visibility procedures. And that would equate in that particular, and it was a 2-runway airport, so one for landing, one for takeoff. So in both landing and takeoffs, there was an additional 24 additional landings. Well, what does that mean? It means compliance, you achieve availability. Traffic density is increased, airport revenue is increased. And you remember, when we are doing our job effectively, nobody pays a lot of attention to you. But when something goes wrong, everybody knows your name. You're the most popular name on the airport. Why? Because the decisions you've made maybe are based upon the older methods of preventive maintenance and not made with the equipment that's available to you today on performance-based maintenance. So we're going to now go into a period of if there's any questions, etc. And I say the panelists today is Rob, Robert Shapton, and Tony Smith. So if we do have any questions, please bring them up now, because I know there has been quite a lot of discussion about the whole element of asset management, and we want you in your airport to be the most effective maintenance team available on this planet. We see in TMS with our customers through the cloud, we see the real-time results of your photometrics, and we can observe and see how you are performing your maintenance. Now, of course, that information is obviously confidential, and it is not released to anyone other than yourself. So, okay, so maybe we could all join back in, guys, and Robert, I know you had a particular subject that you was going to bring up, because from those results that we observe from the photometric testing, we know that some airports will undertake photometric testing, for example, according to what is the minimum requirements in an airport. And the minimum requirements say a nominal once every minimum of once every 6 months. But if you're measuring performance and your performance has dropped after 1 week or 1 month, it's pointless measuring every 6 months. What's your view on that?
Well, the key thing we have, the key thing is we talk about in many of your presentations, Keith, is you can't manage what you don't measure. Mr. Ahmad has sent in a question here asking what is the difference between preventative and predictive maintenance. And this is something that we've been talking about, Keith. The simple answer is preventative maintenance relies on best practices, but predictive maintenance takes the measurements from maintenance activities and uses them to help you plan, to predict what's going to happen in the future, and therefore plan preventative measures to stop it happening in future. Which comes round to what we were discussing earlier, is that now we have, through the development of the measurement tools we have, we've got a great deal of data now that we can now start to harness to help airports enhance their maintenance systems, moving away from traditional best practice, which would be to analyze analyze the faults and then send someone to go out and fix them, but to be able to use that data to be able to look at the trends, to be able to see what's happening, and then to put in place measures to prevent the conditions that could result in unserviceable lighting. So and that can be as simple as some airport customers of ours have been using the worst lights reports, the worst 20 or worst 30 lights. You can set the data accordingly and rather than wait for lights to deteriorate below the 70% level that is written in ICAO for carrying out preventative maintenance, they will actually start carrying out preventative maintenance on lights well above that level, so they never even reach the maintenance level. That achieves two things. One, you never have unserviceable lighting conditions, which of course is a I think I've used the terms a legal requirement. It's a part of your operating license as an airport to operate only a serviceable runway lighting system. And secondly, it is also an awful lot more efficient because planned maintenance is much more efficient than unplanned maintenance. You don't have to, it's not reactive. If it's just in the course of just keeping on top of your maintenance, just seeing to a few lights every time you have to make an intervention on the runway minimizes the amount of work that is ever done on the runway and any interruption to air traffic. And this comes on to our offer to all of our customers, all of the airports listening to this webinar today. We would like to extend an offer to you to provide services to help you, to work with you, to develop our predictive maintenance algorithms, to use to develop our technologies, our linear programming and other artificial intelligence algorithms, programs, to be able to take that data that we have collected, that you have collected for your runway lighting systems, to be able to analyze it, to help you to understand it better, to be able to use it and interpret it and improve your runway lighting maintenance, such that you can achieve not only compliance, but even more efficient compliance by anticipating future conditions, identifying what maintenance works better than other maintenance. So, for example, we've already started working with some airfields. An example would be looking at sapphire coated lenses versus traditional airfield lighting lenses. We're seeing particular issues where lenses are becoming damaged, impairing photometric performance for various reasons: jet blast, environmental conditions such as sandblasting from desert conditions, for example, to damage caused by de-icing equipment. And we're finding that investment in certain circumstances, investment in sapphire coated lenses is a very, very worthwhile investment, requiring less maintenance in future. Indeed, I've even seen on some airports in icy conditions, I've seen that the sapphire coated lenses, albeit they're more expensive, but they're actually out surviving the light fixtures in which they're put in. The actual metal around the lenses is being damaged to a point, and the gaskets are being damaged because the metal is being worn away. And one airport in particular, is actually looking to reuse the lenses from light fixtures that have been severely damaged by their de-icing equipment, because the lenses have actually survived it, which is quite incredible to me, but I've got the photographs to prove it. So there's a number of ways, Keith, in which we can do this, but we're looking to work with airfields to develop these algorithms and to help airports better predict the future outcomes of maintenance activities, to allow them to enhance their performance, to reduce the mean time between failures of their assets, and to hone a more efficient and a more effective maintenance practices.
I think this you're quite correct there, Robert. I mean, you get the measurement, accurate measurement in real time, and I'm talking about accurate and repeatable measurement in real time. Then when you have those that information, then of course Rob's capability, with his equipment, enables us to quite accurately determine, as you said, mean time to failure, etc., and the element of the sapphire lenses is an ideal identification of how we can improve the performance of airfield lighting, or demonstrate the performance of airfield lighting, and also enable an airport to make a calculated assessment on their return of investment for, say, for example, changing to sapphire lenses rather than the traditional lenses. Yes, and excellent. The other aspect of which is it keeps coming up in terms of is as we've moved from tungsten halogen to LED, and this is a question that's been thrown at me several times, is of course, if we're looking at certain applications, the use of the night vision concept of the night vision goggles, etc., with LEDs, because you know the thermal signature associated with tungsten halogen fittings does not exist with LEDs, and that is something where is that something which perhaps that we could assist with when it comes to looking at the next generation, which we are working on, of MARMS technology.
I say, Keith, that's a very interesting area, because I think it's come as a bit of a shock to the image intensifier world to suddenly find that another bit of the aviation industry is almost destroying their offer, because we're no longer emitting infrared energy. But I would say that that's where you need to have a dialogue, and the people that want to use that technology need to be in the dialogue with the people who are making the lighting equipment, because I can say from personal experience, having done trials all 25 years ago with night vision goggles, it's perfectly feasible to replicate the patterns that you get on with normal lighting, runway edge and so on, with LEDs that emit in the near infrared region. And that has all sorts of possibilities, positive things that could potentially be built into your LED light source, that it does emit near infrared and enables the lighting to still support approaches where people are wanting to use night vision goggles. It needs development work doing, but the potential's there because we did it.
Well, yeah, it's just I bring this up as part of, as you know, as we move forward in our digitized world into our artificial intelligence world, then of course it's a subject that now increasingly comes up. And only yesterday I was visiting an airfield, and where they were looking for LED lighting fixtures that could be used in this application.
Yeah.
So yes. So anyway, so you're coming back to the preventive, and several questions have come up about the preventive maintenance, the predictive maintenance. As I said right at the beginning, predictive maintenance, we've been doing predictive maintenance in its pure form when we were looking at doing block changes. It's just that the information that is available today using the technologies that exist today, and as we are moving forward in doing, as Robert says, with algorithms, etc., to be able to more effectively predict, then it is important. We are, I'll repeat again, we are asking for airports around the world in the different geographical environmental locations to participate with us. And we would love to hear from you.
Yes, I mean, there've been a few examples of airports that that have engaged in research using the data. And so the example of sapphire coated lenses I gave you earlier, there's also a couple of examples of airports that have used looking at the mean time between failure of their halogen lighting. Mean time between failure is of course, we're talking about measuring the measurements to show how quickly their lighting becomes unserviceable, similar to that cleaning example that you presented earlier. But using that, because there's a cost of doing maintenance on the runway. You know, in the case of inset fixtures, that always means the light has to be well, assuming
Robert, I will always repeat a previous statement. If you think maintenance is expensive, try an accident.
Mm-hmm. But of course, if you're having to, in some cases, the runway lighting is becoming unserviceable weekly, and the extent of having to replace fixtures on the runway is so great, that can often can be evaluated with a view to justifying the investment in upgrading to LED technologies, which many airports have done, because it's part of the business case. If you're spending, I've seen a cost of £250, let's say €300 is the cost of changing a light on the runway, each light. So if you factor that in, clearly the potential for LED lighting, you know, that's one of the potential benefits for LED lighting.
Well, also the element, Robert, is the availability of tungsten halogen lights and lamp fixtures, lighting lamps in the future, because we all know that that in the industry, in general industry, the future of tungsten halogen, the filament lamps have gone. Mm-hmm. And whilst we are still have the availability of a tungsten halogen lamp unit for the airfield lighting, for how long before the manufacturers decide it's commercially not viable anymore?
Right. So, Keith, we've reached the magic hour of 3 o'clock. So what I'd like to do is just say that, you know, repeat our offer to all of you airports out there to work with you to support your development from of your maintenance systems into predictive technologies to enhance the efficiency and the effectiveness of your maintenance, AGL maintenance. But if I could just go around before, give a closing word to each of you, starting with you, Keith, on this topic, and then we will formally come back to you on all of the questions, any unanswered questions on our website, including the recording of today's webinar. So you will have an answer to all of your questions posted onto our website. Also, I'd just like to mention that our next month's webinar is on the hot topic of apron and stand lighting. How do you measure it? What is the business case for it? Because this is something our customers are asking for us more and more because of a number of issues. So how to measure apron and stand lighting and the business case for doing so, and the challenges airports face actually doing this. So that will be the subject of next month's webinar, the last Tuesday of the month, of course, as usual. So Keith, what would you like to say to our audience to encourage them towards the world of predictive maintenance?
Well, I would like to say is repeat the statement that we want our aircraft to be operating safely. We need the systems of our that we provide to support that safe aircraft operations to work effectively, both the equipment on the ground that is operating, but the tools and equipment that you use, and the processes that you adopt to make your decisions and undertake that work. And of course, us as people, are we competent? Can we justify our competency? And certainly over the past month, we have been exceedingly busy providing competency-based training and assessment to various locations around the world. So those are the four elements.
Absolutely.
Your equipment on the ground, the tools and equipment that you use, and the processes, etc., which Rob has explained and does.
And
thank you.
Thank you, Keith. And Robert Billingham, as the master of the machine engineering, the automated artificial intelligence, are you ready for the our audience to swamp you with requests for assistance?
Yes, yeah, but very excited for this. I mean, machine learning, artificial intelligence is a big interest of mine. I mean, we'd be looking at data from all aspects of the airfield maintenance, from photometrics through to the workshop testers, the sign PAPI testing. I mean, you need to incorporate data from weather, de-icing events, all sorts of things all come into play. Yes, so very excited to work with anyone who'd like to get involved.
Thank you, Robert. And not last but not least, Tony.
Yes, I'd like to pick up on Robert and say to emphasise the importance of airport staff maintaining this lighting, as we've been discussing this afternoon, the importance of it, all the reasons have been given. And I think the recent discussions I've had with you have just highlighted another hole, if you like, that can appear in the totality of the safety sum. If, for example, your approach lighting is under a different management to your airfield lighting, your in-pavement lighting, your runway lighting and your PAPI and so on. If that is so, you have the danger of the approach lighting, for example, being quite close to the specification in terms of output, and yet then you have a black hole, which is the airfield itself, because the maintenance we've been talking about this afternoon, particularly in relating to the runway lighting, is not being done. And that is a potentially very dangerous situation. And in fact, that happened in the past, where there are accidents where people got good contacts on the approach lighting, made a decision to land, and then had inadequate visual cues when it came to the flare and landing. And so that's just something else to toss into the totality. There needs to be a real overview. You need to be sure that the bits, perhaps the bits you're responsible for, are up to spec, because other bits may be, and yours not being, may actually be generating a safety issue.
Thank you, Tony. And yes, indeed, Tony is Tony's actually provided us with film of such an example, which demonstrates an airport in low visibility conditions where on the approach, the lights are quite clearly visible, but on descending to land, the lights, because of a shallow fog and poor lighting conditions, the combination contrived to actually result in having the pilot being able to see no lights whatsoever at a height of around about 100 feet just coming into land, which is, you know, clearly quite an issue, and could actually contribute to a very serious accident under certain circumstances. As I think you've probably seen from our presentations before, the risk of a landing increases exponentially in low visibility as a visibility reduces. So it is the duty of all of us to ensure that that lighting, when the pilots need it, is compliant, and we're here to help. So without any further ado, I'd just like to thank you all. I'd like to thank our Tony, Keith, and Robert, and not to mention Felicity and Damon behind the scenes there. I'd like to thank you all for your contributions today, and most of all, I'd like to thank our audience for taking the time out of your busy schedules to join us, and look forward to seeing you at the same time, same place next month. Thank you very much, and have a nice day. Bye.
Bye.
Bye.